Welcome to class today, geometry students. This Monday, November 4th. Proud of what listen and learn. Take some really good notes. Your quizzes were really good the last time, and so I'm proud of you guys there and what you did. And let's quickly look at some announcements and get today going and go from there. You will have a test tomorrow and Wednesday. Now remember, tomorrow is the fill in the blank part, and we're going to go over in just a second exactly what will be on the test. Okay? Fair enough. So there you go. So a test tomorrow. Tomorrow is going to be a really quick fill in the blank test, and then you're going to work on your review sheet for the rest of the class period. Number 2, everyone already turned in Friday's homework, so you finished the video early, you already turned it in, so you're good to go. Jasa, your quiz, you were absent Friday. And actually, I'm wondering, Jasa, I had down a grade for you already on this. I wonder if you did that a day early. I'm kind of confused. Or maybe you were absent Thursday. Well, either way, and maybe you weren't absent at all. Maybe I'm confused. But since I'm not sure if you've taken your quiz yet, and I've been thinking since we start a test tomorrow, if you would like to totally skip this quiz, now hear me out though. Students, I'm not showing favoritism. The only reason I'm doing this is we're so close to a test. If you want to skip the quiz, and then whatever you get on your test will also count for a quiz grade, so your test grade will also be a quiz grade. If you want to do that, feel free to do that, Jason, if it helps you. Now, if it doesn't, and you want to take the quiz today, you must take it by today. That's totally fine. Mr. Harmon has the quiz. Just ask him for it sometime today, and you can take it. Okay? But if you would like to skip the quiz, and then whatever you get on your test will count for a test and a quiz, that's fine also. I hope that makes sense, and I'm going to leave that up to you. Did you notice on your last quiz I gave everybody 5 bonus points? And I'm just going to start doing that from now on. We're going to do a new bonus system, a bonus point system. I've really gotten away from remembering to give you guys bonus point problems on during your notes. And plus, you got to keep track of your bonus points and all that stuff. Now, we know for a test, the only way you get bonus points on a test is by doing the review sheet. And some of you are kind of funny. You still like right on top of your test, 7 bonus points and stuff like that. There is no need to write anything on top of your test. On a test, I check your review sheet. If you did it, you get 5 bonus points. And if you didn't, you don't. It's that simple. But I want to start a new bonus point system for your quizzes. If you are all caught up on your homework, all your homework's turned in, and you're behind on nothing when we take the quiz, then I will automatically give you your 5 bonus points. So I'm always going to give you 5 points on a quiz just to help you, as long as you're totally caught up. Now, if you're behind on 1 assignment, or 2 or 3, you will not get the 5 bonus points on your quiz, okay? So that's how we're going to do that from now on. That way I don't keep forgetting to give you guys bonus points in class, and this also rewards you for being caught up on your homework, and it also motivates you to stay caught up on your homework too. If you have any questions on anything I've said, call me or email me, okay? Call me or email me. That's 965-2675, okay? So call me or email me if you have any questions at all. All right, let's go ahead and go over what will be on the test tomorrow. Let me quickly grab a drink of water. And these are the theorems, postulates, corollaries, definitions that will be on the test tomorrow. I think there's only 7 of them. So, it's going to be fill in the blank. If you guys can really nail this, focus all of your attention tonight on these 7 thoughts, I think you can do really well on the test tomorrow. Okay? All right. I'm going to give you the definition of congruent figures. It's going to be fill in the blank, so know that. I'm going to give you the side postulate. It's going to be fill in the blank. So know all the keywords and memorize these. One of you is asking me, how do you study for this? You memorize them. You just know them. You know if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. You memorize it. Congruent figures. Figures in which all corresponding angles and all corresponding sides are congruent. And then, of course, it's going to be fill in the blank. So I'm not asking you to quote these, but I am going to make these fill in the blank. So here's here's another one you need to know, side, angle, side. Here's postulate. Here's another one you need to know, angle, side, angle postulate. And boy, it's pretty much self-explanatory. I mean, side, angle, side means if you have a side, and then if two sides, then included angle are congruent to two sides and an included angle in another triangle, then two triangles are congruent. I mean, angle, side, angle. I mean, it's pretty self-explanatory. If two angles and the included side are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. That's why we call it angle, side, angle. So these really aren't that hard to memorize. I mean, SSS means if three sides of one triangle congruent to three sides of another, then the two triangles are congruent. And then three others, angle, angle, side theorem, and that's pretty easy. If two angles and a non-included side are congruent to two angles and the corresponding non-included side, then the two triangles are congruent. And then hypotenuse leg theorem. If the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and the leg of a second right triangle, then the two right triangles are congruent. Students, all that I do when I make your test is like cut and paste these. I don't change any words. I don't type any of this stuff. I really don't. I just cut and paste this, put it on your test, put blanks in for some of the words, and that's it. So it's going to be just like this on your test tomorrow. Now this one we're going to learn later today. In fact, this is what we're going to learn today. It's called the angle bisector theorem, and we'll talk more about that later, but you are responsible for this. This will be on the test tomorrow also. So tomorrow is just the fill-in-the-blank part of the test. Okay? All right, continuing on. Let's go ahead and get ready to take some notes for a little bit. It should be a pretty short lesson today. I think you'll be able to get the notes done and also get most of the homework done in class and be able to study for your test tomorrow. Okay? So here we go. We're going to talk today about something called the angle bisector theorem. The angle bisector theorem. Now, notice it's lesson 5.6, part 1. I'm going to go ahead and tell you now, we were not able to finish chapter 5 by the time we had the test on Wednesday, Tuesday and Wednesday. We are going to finish chapter 5 on Thursday and Friday, and those lessons will be on your next test along with chapter 6. Okay, so we're not skipping them, but I had to go ahead and stick with this test because I did not want to give a Thursday test or a Friday test. So, lesson 5.6, part 1, and notice the date today is the 3rd, or 4th, excuse me. I'm making this video Sunday night here, so my brain is thinking the 3rd. The date is the 4th, November 4th, and again the lesson number is 5.6, part 1. The angle bisector theorem. All right. We must first discuss this phrase. Are you ready? Write this in your notes. The distance from a point to a line. Please copy that in your notes. The distance from a point to a line. Would you please copy that phrase in your notes? We need to talk about that because if we don't, you're not going to know what that means. And if you don't know what that means, then there's no way you'll know what this theorem means right here. Okay? So we need to most definitely go over what this phrase right here means. So go ahead in your notes, write this phrase down, and then go ahead and draw a line like I'm doing. And then we'll put a point somewhere up here is totally fine. Okay? So draw a line and put a point. Now, would you listen to me carefully, please? If I said, what is the distance from this point to the line? You would say, well, Mr. Earhart, there's a lot of distances. It could be that distance, or that distance, or that distance, or this one, or this one, or this one, or this one. I mean, when someone asks you what is the distance from the point to a line, it could be a lot of different distances. Now, if I ask you what is the distance from a point to a point, that's easy. There's only one distance from a point to a point. But when someone says to you, what's the distance from a point to a line, there's a lot of answers, except here's what I want you to know. In geometry, when we refer to the distance from a point to a line, we're referring to the one distance. Are you ready? Write this down, please. We're referring to the one distance that is a perpendicular line. So, if I draw a perpendicular line from the point to the line, that is the distance I'm talking about. Let's go over that again. When I say to you the distance from a point to a line, I am referring to the perpendicular distance, or in other words, the distance from the point to the line that forms a perpendicular line. Not this distance here like this. That's not a perpendicular line. Or not this distance here. That's not a perpendicular line. Or not this distance here. That's not a perpendicular line. When I ask you, or when I refer to the distance from a point to a line, it's a line that you draw from the point to the given line that is a perpendicular line. And that's what we're referring to. Back this up and listen to it again if you need to. You've got to understand that, or you're not going to understand the theorem. Okay? Now, I would like you to write this theorem down, then I'm going to give you a picture of it, and then we're going to talk about what this means, work on a couple of problems, and that'll be it for the class period. Okay? So here we go. Theorem 5.3 states the following. It's called the angle bisector theorem. If a point is on the bisector of an angle, let's stop right there. Mr. Aaron, I forget what the bisector of an angle is. Okay, I'll show you. Here's an angle. A bisector is the line that cuts the angle right in half. So in other words, this angle here is congruent. Let me fix that real quick. This angle here is congruent to this angle here. Okay, that's an angle bisector. It's an angle, it's a line that cuts an angle in half. Let's continue on. If a point is on the angle bisector of an angle, then it is equidistant from the two sides of the angle. Let me read it one more time, then show you what it's saying. If a point lies on the bisector of an angle, then that point is equidistant from the two sides of the angle. So, I'd like you to write this in your notes if you would, please. Go ahead and draw an angle like this. And then go ahead and draw an angle bisector like this. And do the best you can to make sure that that line cuts the angle right in half, okay? And so go ahead and mark, please. Would you go ahead and mark this angle here with 1 slash and this angle here with 1 slash, because those two angles are congruent, because this black line is supposed to be an angle bisector. Now go ahead and pick a point anywhere you want, and we're going to call that point A. Point A, okay? Now here we go. Are you ready? If a point is on or lies on the bisector of an angle, so point A lies on the bisector of an angle. This is a bisector because it cuts the angle in half. If a point lies on the bisector, which A does, then this point is equidistant from the two sides of the angle. Now what that means is if I draw, remember we talked about earlier right here, I said from now on when we talk about the distance from a point to a line, it's got to be a perpendicular line. Got it? Let's apply that over here. This point is equidistant from the two sides of the angle. That means if I draw a line right here from this point, and remember it has to be, I'm going to do this and change colors here. It has to be a perpendicular line, so it comes down and it hits right there, perpendicular. And then same thing here. This has got to be a line that's perpendicular. There we go. I know my drawing's not perfect. I know those two green lines don't look the same length, but theoretically they're supposed to be, okay? So if a point lies on the bisector, and we already mentioned that A definitely lies on the bisector right here, then that point is equidistant from the two sides of the angle. So we're going to call this a length of 5, and we're going to call this a length of 5. They're the same. So let me quickly review what has to take place for these two segments here and here to be congruent. First of all, you must have a slash here and a slash here, because when you have a slash here and here, that means this line in the middle is an angle bisector. So you must have congruent angles here. Number 2, you must have this point right here lying on the bisector. And then number 3, you must have right angles right here. Now I'm going to go over that again for you. Alright, and then we'll go ahead and work some problems out. How will I know when this segment here is congruent to this segment here? I'm going to tell you one more time. You need three things. First of all, this angle here has to be congruent to this angle here, and notice they are. Secondly, this point right here has to lie on this line right here, and notice that it does. And then thirdly, you must have right angles here and right angles here. In other words, they must be perpendicular to the sides of the angle. When those three things are present, then you know that this segment here is congruent to this segment here. And that's what the angle bisector theorem states, okay? Now with that in mind, let's go ahead and work on 1, 2, 3 problems, and then I'll give your homework to you. And I was going to change that homework. Let me see if I did. It looks like I did. I was going to take off 33. It was a really long proof, and we've done so many of those lately. Y'all have done so well on those. I was going to give you a break on that today, just a little bit. Okay? All right. So let's go back real quick here. Okay, here we go. Let's go ahead and work on 3 problems. Now, let's try this problem here. Go ahead and copy this in your notes if you would, please. Go ahead and copy this in your notes. And by the way, if you'll give me just a second, if you don't want to copy that in your notes and you want to save yourself some time, I will give you a page number on this. Instead of copying that down, if you just want to write, it's up to you, page 274, number 1 at the bottom. That's where we're getting this problem from, so you can copy the problem down in your notes, or you can write this in your notes, and then we'll go from there. You can go ahead and open your books to this page and look, and just write this in your notes. It's up to you. Okay, here we go. Are you ready? Do we have that this angle is congruent to this angle? Yes, we do. Do we know that this point right here lies on the angle bisector? Yes, we do. And do we have a right angle here and a right angle here? Yes, we do. So we definitely know that this segment here is congruent to this segment here. Got it? So I know I can say x plus 3 equals 2x plus 1. Now let's go ahead and find the length of FH. They want us to find this length right here. Now you can't find that length until you find x first. So let's solve for x. Let's bring this x over, and when we do, it will become a negative x. So it's gone, and now it's right here. Let's bring this positive 1 over, and when we bring that positive 1 over, it's going to become a negative 1, and now it's totally gone. So we're left with 3 minus 1 is 2, and then 2x minus 1x would be 1x. And of course, students, 1x is the same thing as just x, so we have x equals 2. Now, if I would have asked you to solve for x, then you'd be finished. You would circle it and you'd be done. But I did not ask you to solve for x. I asked you to find the length of FH, and the length of FH is x plus 3. So if x equals 2, then we're going to put a 2 right here for x, and 2 plus 3 is 5. So the answer is 5. The length of FH is 5. Let's try another one. If you don't want to copy this down, I'm going to tell you right now it's on the same page. So page 274, number 2 at the bottom. Okay? Now, here we go. Do I have this angle here congruent to this angle here? Yes, I do. They're marked congruent. Do I know that this point right here lies on the angle bisector? Yes, I do. And do I have a perpendicular or a 90-degree angle here and a 90-degree angle here? Yes, I do. So because those 3 things are all present, then I know I can use the angle bisector theorem, which states that this segment here is congruent to this segment here. So I know that I can state that 4x equals x plus 15. Now I'm going to bring the x over, and when I do, make it a negative x, so now the x is gone, and 4x minus 1x would be 3x equals 15. Divide both sides by 3, and x equals 5. Now I would be finished if I would have asked you to solve for x, but I did not ask you to solve for x. I asked you to find the length of mk, this length right here, mk. Well, the length of mk is x plus 15, and x is 5, so I'm going to substitute a 5 right here. 5 plus 15 is 20. So the length of MK is 20. One more, then I'll give your homework to you, and I'm going to talk to you a little bit about your homework. Now, here we go. They want us to find the length of AD. AD. Now, if you want to write this in if you want to write down the page number, instead of copying this problem down and turn your books and follow along, that's up to you. Or you can copy this problem in your notes. Whatever you prefer is totally fine with me. You will find this problem on page 276, number 3 at the top. You'll see it if you look at the top of the page. Now here we go. First of all, do I have this angle here is congruent to this angle here? Yes. Do I have that point D is lying on the angle bisector? Yes. Do I have a perpendicular, or do I have a 90-degree angle here and here? Yes. So because all of those things are present, then I know for sure that this length right here, AD, is congruent to this length here, DC. And there's really no math to do on this at all. If this length right here is 16, and they want us to find the length of AD, I mean AD also has to have a length of 16. So the answer is 16. Let me fix that real quick, 16. Okay, so there we go. Not a very hard lesson, pretty simple, and a pretty small homework assignment. Now, you might finish early in class today. I would encourage you to sit there and write out those 7 phrases that I want you to know for your test tomorrow. Theorems, postulates, corollaries, definitions. I would write them out 2 or 3 times each. I really, really would. That will help you get them really drilled into your head. But that's up to you. But that's what I would encourage you to do if you get your homework done. Now here is your homework. I need to talk to you about this. We have now hit a point in the year where I'm able to start using videos from last year's geometry class. It was a class that had Megan Sheets in it, Kate Daglion was in it, Tara Guest was in it, and Ashley, I always did kind of butcher her last name, but I think it's Ashley Rufinoff, but Ashley was also in that class. And you say, well, Mr. Earhart, you didn't start teaching that class until January. Are we already doing stuff that they were doing in January? Well, remember, when I took over in January, they were actually, I had to go back and teach a couple chapters they had already had. So we're not really, I think we're a little ahead of them. We're probably pretty much where we need to be. But because I took over in January, they were a little behind because they had fallen behind in class. I had to go back and reteach a couple chapters. So we are now at a point, please listen to me carefully. I'm always going to make videos for you guys, okay? I think I should make it very personal, and I'm going to do that. But when it comes to homework help videos, there's no need for me to redo those. That's just a waste of time. So when you listen to Caleb on video, buddy, hey, video. When you listen to this homework, when you watch the homework help video, from now on the rest of the year, if you hear something like, maybe I say something to Tara or Megan or Kate or Ashley, just ignore it. And if you hear something during the homework help video like, now in tomorrow's quiz, just ignore that. Or something like, now because this is a Friday, this is not due until Tuesday or something, just ignore that, okay? Because anything I say in these videos in reference to tests or quizzes or due dates or anything like that, that's for last year's class. The only thing I want you to get when you watch the homework help video for this homework assignment, just listen to how the problems are done, and that's all that you need to worry about. And that'll be that way for pretty much the rest of the year now, okay? We're not doing number 33. All that you're doing are 5 problems, numbers 4, 11, 14, 15, and 17. And if you'll look there at your list of videos, you'll see there's a homework help video for this assignment, okay? If you have any questions, call or email. Hope you guys have a great Monday, and please be ready for your test tomorrow.